Right now we will discuss the methods of preparation of amine. Amines are regarded as derivatives of ammonia in which one, two or all three hydrogen atoms replaced by alkyl or aryl group. For accordingly we will prepare primary amine, secondary amine and tertiary amine. Right? So right now we will discuss the methods of preparation of amides. It is the most important aspect, the methods of preparation of amine. So we know various methods of preparation of amine, those we have already discussed. So first we will discuss the methods of preparation of reduction of amides. Reduction of amides. Amides are reduced to the corresponding amines by lithium aluminum hydride or sodium in presence of ethanol. Primary, secondary or tertiary amines can be prepared by this method, by the reduction of corresponding amides. You know amide, which is the functional group is R bond C double bond O bond NH2, this is called amide, and we will take here lithium aluminum hydride, or we can say we can take also ether in presence of water. Then it will give us amine RCH2 NH2, it is amine. Or in this method we will prepare primary amine, secondary amine and tertiary amines, right? So we are using here the reducing agents lithium aluminum hydride, which is very costly in nature, or we can use sodium with ethanol, right? Secondary and tertiary amines can be prepared by the reduction of secondary and tertiary amines respectively, right? We can prepare also secondary and tertiary amines from amide. Then we will move to the next methods of preparation. We will take here ketone, right? Here we will take a ketone. In ketone we will give here NH3. NH3 means we will give ammonia, right? In ammonia, then we will just give heat in removing water, then it will give us dialkyl. Dialkyl means it is R group, it is R prime group. These are called alkyl group. Dialkyl ketimine. This is called double bond NH. This is called dialkyl ketimine. We will give in dialkyl ketimine hydrogen and nickel. Right? It is the also reduction process. Then it will give primary amine. It will give primary amine. Why? Now amine bond NH2 group is bonded directly one carbon atom only. That's why it is called primary amine. Okay. So right now we will discuss the next methods of preparation, that is by reduction of oxygens. Here we will take R CH double bond NOH. This is aldoxym. Okay, aldoxym. We will give here hydrogen atom, 4 hydrogen atom. We will do here reduction process and we will give lithium aluminum hydride LiAlH4 lithium aluminum hydride or sodium with ethanol. Then it will give us first degree amine or primary amine with water will release, right? Then the next methods of preparation is reductive amination of aldehydes and ketones. Right now we will take aldehyde. You know aldehyde functional group is R bond C double bond O bond H. R bond C double bond O bond H. So it is aldehyde. Aldehyde when react with the ammonia NH3 will give heat and will remove water. Then it will give imine. Means R bond CH double bond NH. Here we will get nitrogen and hydrogen NH. Okay. Another H2 and O become water minus water. Right now I will tell you the mechanism. Here NH3 from NH3 NH will be bonded here. Double bond NH. Okay. You know nitrogen valence is 3, so double bond and bond H. And here one H2 hydrogen 2 and one oxygen. It will become minus H2O. Correct. So it will give imine. So H2, here we will give H2 with nickel metal, then it will give first degree amine RCH2NH2. We will get here primary amine. Okay, here we will get primary amine. Then we will discuss Hofmann bromamide degradation method. Hofmann bromamide degradation method. It is one of the important methods of preparation of a primary amine. So right now we will discuss primary amines can be prepared from amides by treatment with the Br2. Br2 means here we will give bromine, right? And KOH. KOH means potassium hydroxide, or NaOH. NaOH also we will give sodium hydroxide. The amine formed contains one carbon atom less than the parent amide, right? Whatever amide we will take here, suppose we will take methanamide or ethanamide or propanamide, butanamide, pentanamide, likewise. So any amide we will take, any amide, so we will get a less than of the carbon atom. Okay, less one carbon atom. Fine. So therefore this method is used for stepping down the series in organic conversions. Okay, for the organic conversions we will use this method for the stepping down, right? So right now here we will take R bond C double bond NH2. Here R we can take methyl group, ethyl group, propyl group, butyl, pentyl, hexyl. You can take also, no problem. So it is R CONH2 or amide. Here we will give Br2 means bromine water in the presence of potassium hydroxide. Here we will take for balancing the chemical reaction, we will take the 4 mole of potassium hydroxide. Then it will give us RNH2, means it is a primary amine, or you can say first degree amine with K2CO3 potassium carbonate and 2 kBr potassium bromide and 2 moles of water molecule will release. This is Hofmann bromamide degradation reaction. Basically this reaction involves the migration of alkyl group from carbonyl in the precursor to nitrogen with the elimination of carbon dioxide. Fine, elimination of carbon dioxide. Therefore the reaction provides the product containing one carbon atom less than the starting material. Okay, less than the starting material. So this is all about Hofmann bromamide degradation reaction. So right now we will discuss one of the most important reaction, that is Gabriel thalamide synthesis. The reaction name is Gabriel thalamide synthesis. Actually this method is used for preparing only primary amines. In this method thalamide is treated with potassium hydroxide. The condition is alcoholic potassium hydroxide, right? Potassium hydroxide we will take aqueous potassium hydroxide as well as alcoholic potassium hydroxide. Here we will take alcoholic potassium hydroxide to give potassium thalamide. This is called potassium thalamide. Here you will see K is present. Here we will get K. KOH is break down to K plus OH minus. Here we will get K. So here OH and here H become water minus H2O. So this K is bonded here. So it will give potassium thalamide, which is treated with alkyl halide or benzyl halide to form N-alkyl. Okay, which form N-alkyl. N-alkyl means N-ethyl, N-methyl, N-propyl, likewise. So N-alkyl thalamide. So the hydrolysis of N-alkyl thalamide, okay, hydrolysis. Here the process is hydrolysis. Hydrolysis process with the 20% hydrochloric acid we will give under pressure or refluxing with the sodium hydroxide give primary amine. Here we will get C2H5NH2. This is ethanamine. We will get a primary amine. Here this is the phthalic acid is the byproduct. Okay, this is the important methods of preparation of amine. Dear students, you will prepare regularly for these methods. In all the organic methods of preparation, not only for amine, whatever methods of preparation you will you will practice it is every day. Every day you will see at least 2 to 3 minutes. See the reactions only, what are the reagents we will give. So this is the important aspect for the methods of preparation of amine. So We know also aryl halides cannot be converted to aryl amines by Gabriel synthesis, right? Once again remember all of you, aryl halides cannot be converted to aryl amines by Gabriel synthesis because they do not undergo nucleophilic substitution. Once again, nucleophilic substitution with potassium thalamide. Okay, so aromatic primary amines such as aniline, toluidine, etc. cannot be prepared by this method. Okay, understood all of you? Thank you all of you.